I'll be demonstrating our system programming project, which is a complete user space virtual file system written in C++. The project simulates a block device using a disk image file and implements a Unix-like file system with inodes, directories, permissions, and hard links. Now I'll walk through the compilation, core features, and then finally show persistence across its restarts. Now we begin by compiling the project and launching the virtual file system shell. Now run it. Now first of all, we initialize the virtual disk image using the mkfs command. This sets up the superblock, inode tables, and internal metadata structures. And after that, we mount the file system to make it accessible. So now I'll type mount. So the disk will be mounted. Now we can perform basic file operations such as creating files, writing data, and reading it back. Now let me just show you. Create log.txt. Sorry, my mistake. Now let us see that the file is working. As we can see, the data is read back successfully. Now, the file system supports full hierarchical directories with proper path navigation. And we can create directories and work inside them also. Like if I do mkdir docs, then I can create the directory, and now I'll traverse it. And let's make something in that. Create secret.txt. I'll create it. Now let me write it with secret.txt. It is confidential. Okay, so we have got these files, and we can now display it also. Here the output shows the file inside the directory along with its permissions, size, and metadata also. And moreover, we have also implemented Unix style hard links using inode reference counting. A hard link creates another file name that points to the same inode. Like, let's make a hard link ln secret.txt, and let's make another file lis.txt. Now hard link is created, and now if I try to list it, now both of them are being shown. Now notice that the link count is now 2 for both files, which means both names refer to the same underlying inode. And now if we delete the original file, the data is not lost because the inode still has a remaining reference. Like if I remove secret.txt, it is removed, And now if I try to view what is written in alias.txt, the data is still accessible through the remaining hard link. Okay. And now the system also enforces safety checks also. And now the system also enforces safety checks. For example, it prevents deleting non-empty directories. If I move back to previous directory and if I try to remove docs, it will say error -7, it is not empty. So to delete the docs directory, we first have to delete the alias.txt and make it empty, then we can remove it. And all file system changes are immediately persisted to the disk. That means to demonstrate this, we exit the shell and restart it. Let us do that. Exit. And now we give it first of all and /vfs.exe. And now let's traverse to the previous directory, which was docs. Oh, sorry, I forgot to mount it. As shown, the data is still present after restarting, which confirms the persistence. Now before concluding, I'd like to briefly mention the optional bonus extensions described in the assignment. For the user interface, the bonus points are awarded for replacing the standard interface with a themed UI. For this WOC 8.0, it is Halloween, so you can use a Halloween themed UI. And in a terminal based system like ours, this could include themed prompts or styling. And for the backend part, which you will be writing code and structures, additional bonus points are suggested for introducing special features such as horror themed function or internal structure names, even if they are conceptual, are fine. While our primary focus was correctness and Unix like behavior, the design remains flexible enough. Okay. So now this concludes the demonstration of our user space virtual file system. Thank you.